we are going to be discussing properties of numbers. The first property of numbers we're going to be discussing is the commutative property. So the commutative property tells us that the order that numbers are added or multiplied does not change the answer of the sum or product of those numbers. So 3 plus 4 gives us 7, 4 plus 3 gives us 7. Doesn't matter which order, 3 plus 4 equals the same as 4 plus 3 because 7 equals 7. Commutative property of addition. Commutative property of multiplication says the order that the numbers are multiplied. Doesn't matter. Does not matter. 3 times 4, 12. 4 times 3, 12. Doesn't matter. Associative property. So associative property talks about the placement of parentheses. And the way that I remember this is I like to associate with people. It's my group of friends. So associative property is talking about the grouping symbols or how numbers are grouped. So if you look at 3 plus 4 in parentheses plus 5 equals 3 plus in parentheses 4 plus 5, the placement of the parentheses is different. The answer is still the same. 3 plus 4 is 12. Going to do that first. It's in parentheses. Plus 5. 3 plus 4 is 7. Plus 5 is 12. 4 plus 5 is 9. Plus 3 is 12. 12 equals 12. Please notice that the order of the numbers remains the same. It's consistent on both sides, but the placement of the parentheses changes. What you do first, the addition you do first on the right side is different than the addition you do on the left side, but the order of the numbers remains the same. Same as multiplication. 3 times 4 is 12, times 5 is 60, 4 times 5 is 20, times 3 is 60. Placement of parentheses changes, numbers you do multiply first changes, answer does not change. If it's all addition or if it's all multiplication. What's not classified as associative property, even though the position of the parentheses changes, is when the order of the numbers also change. When the order of the numbers changes, the commutative property trumps the associative property. So if you look at the bottom, 3 plus 4 plus 5 equals 4 plus 5 plus 3. Because the order of the numbers change, the commutative property wins. So the bottom example is a commutative property example. Distributive property. Well, it's not really a property of numbers. We discuss it in properties because it has the word property in it. When we talk about properties, distributive property, we can either, and this is a little bit of a shift from order of operations. We can either do the order of operations first, which is 4 plus 5, 9, 9 times 3, 27, or we can distribute that 3 to the numbers that are inside parentheses. When you distribute, you multiply. So you can do 3 times 4, and then 3 times 5. 3 times 4 is 12, 3 times 5 is 15, and in the end you get the same 27 that you get if you were to do order of operations, which would be parentheses first, and then multiply. Identities. When we talk about identities, we talk about numbers that you can either add or multiply to a number where you do not change its identity. You do not change its value. So when we talk about the additive identity, we're talking about adding 0 to a number. Because it doesn't matter what you add 0 to, the number stays the same. 4 plus 0, 4. X plus 0, x. Negative 8 plus 0, negative 8. Additive inverse is the ability to add 0 to any number and not change its identity. Multiplicative identity is you can multiply 1 by any number and not change the value of the number. 4 times 1 is 4, x times 1 is x, negative 8 times 1 is negative 8. You can multiply 1 by any number and not change the value of its number, just like you can add 0 to any number and not change the value of the number. The last thing we're going to do are properties of equations, or equalities. These are a bit different, because now you're talking about how one equality or one equation compares to another equation. Whereas everything you've done before compared one side of an equal sign to the other side of an equal sign. It compared simplifying the right side and simplifying the left side and being able to get to one answer, the same answer. Now you're talking about looking at two equations and saying that they are equal. The two equations are in fact the same. So for the symmetric property, it says if A equals B, then B equals A. What that means is if you take an example like 2 plus 3 equals 5. A is 2 plus 3, B is 5. It doesn't matter if you switch the order, the placement of those two sides. So the right side becomes the left side becomes the right side. 2 plus 3 equals 5 is the same as 5 equals 2 plus 3. Because equalities means that they're equal. The thing on the right equals the thing on the left. So therefore, if you flip it around, the thing on the left should equal the thing on the right. If you have 5 red M&Ms on one side and 5 green M&Ms on the other, if you flip them around, there's still 5 M&Ms on each side. They're still equal. They may be different colors, but they're still equal. Transitive property is the hardest one, only because now you're talking about 3 different equations. It's saying if A equals B and B equals C, then A equals C. What that means is if 2 plus 3 equals 5, 2 plus 3 again is A, 5 again is B. Now 5 is B because B has to be the same thing, and 5 times 1 is C. 2 plus 3 equals 5, 5 equals 5 times 1. Therefore, the A, the 2 plus 3, has to be the same thing as the 5 plus 1. Sorry, 5 times 1. 2 plus 3 has to equal 5 times 1. If 2 plus 3 equals 5, and 5 equals 5 times 1. So if I were to take these two B's out, that's how I get my A equals C. Can you even see that? So again, the first ones that we saw, the commutative, the associative, the distributive, and the identities, are talking about comparing the right side of an equation to the left side of an equation. Whereas when we're talking about properties of equations or equalities, we're talking about comparing one whole equation to another whole equation. Or even going further and comparing 1 to 2 and then 1 to 3. And then creating the third.